Yeah. So again, we'll discuss Kubernetes architecture, and in the Kubernetes architecture, like we have control plane components or master components, and in the master we have like Kube API server, then Kube scheduler, Kube controller manager, then etcd, and additionally we can tell cloud controller manager also. So these all the four or five components we have mainly with the Kubernetes. The first one is the Kube API server. Kube API server is the front end of the Kubernetes cluster. If any of the user communicates either through through the CLI kubectl or through any of the REST APIs or any dashboard kind of tools or third party tools, like Kube API server is the front end kind of thing. Then, like etcd is the key value kind of data store. All the meta information regarding the cluster is going to store in etcd. So then, if someone asks about if you want to take the backup of the Kubernetes, which component backup we need to take? So we need to take the backup of the etcd. We need to take the backup. Okay, so etcd backup, say we need to take. Then what is the role of the kube scheduler is, I have deployed one workload, and that workload scheduler will decide on which node those parts need to run. On which node those parts need to run is going to be decided by scheduler. And the Kube Control Manager handles like whatever the node, if you have any issues on the node level, replications are not running, service endpoints, all this is going to control. What that meaning is, if you have any problem with the node, any of the node health issues or replication kind of thing, make sure those are running or not. Okay, so that is taken care by the node controller. Okay, then what is the update of the cloud controller manager is, so cloud controller manager will integrates with the, I'm going to use AWS or Azure. Okay, so those kind of cloud controllers kind of thing, how to communicate with the load balancer, storage, all these we are going to communicate with the cloud control manager. Okay, so then on the worker node, so very long back we used to call as minions also. On the worker node we have kubelet, kubeproxy, then on top of that container runtime. So, then from the Kubernetes wise we are going to get the pods. From the Kubernetes wise we are going to get the pods. So what is the role of the kubelet is? The kubelet is the agent service, and that would be reporting to the Kube API server, and will take the request from the API server, and it will schedule the workloads also. It will schedule the workloads, and in order to run those pods or jobs, all this it required a container runtime. So we'll have the container runtime, that's maybe container D, CRIO, Docker, any of the container runtime is required. Then kubeproxy, in order to expose those pods, and we need the routing kind of things, that routing is going to be delivered by kubeproxy. So kubeproxy we are going to use for the like a networking and load balancing for the services, and the service will expose also to the pods. Okay, so for that purpose we are going to use like a container runtime.
Sir, is this Kubernetes have more theory?
Yeah, yeah, vast components. It's
Okay,
okay. So we have the vast components, and even application also very vast one.
okay,
Okay, so now whenever the user submits any YAML or maybe to the API server from the kubectl, okay, then scheduler will select that suitable node. Okay, on which node kubelet on that will launch the pod using the container runtime. Kubeproxy also will ensure the pod and that is accessible over the service network. So with that, like kubelet and kubeproxy on the agent side, it would be, and the scheduler will take care on which node that is running. Okay, so then these all the main components we have. Okay. So then here we are going to have the like worker nodes on that. We are going to run it. Okay. So then what is a pod? Okay. So what is a pod is say so the pod is the lowest level of object. So from the AWS wise, we are going to deal with the EC2 instance. On top of EC2 instance, we have the auto scaling groups like this. We have the multiple objects, but here we have the pod is the lowest level of object, which is an encapsulation of one or more containers, their storage and networking as an entity. Even if you see in the EC2 instance, we have the computing resources, then we have the networking from VPC, and we have the storage from the EBS. In the same way, here also we have the pod. So pod can have like a, here in this pod, we can have one or two like containers also, but 90% or 95% it would be one pod and one container would be there. But there are some use cases will have the pod. Pod is like we have like one or more containers also is possible, but it's not a best practice. There are some special use cases. Okay, why we need to go for a pod with multiple containers, but 90%. So we want to keep a microservice very lightweight. That is the reason we are going to keep that pod is only one container. Okay. Then networking, storage. Okay. All if you want to share with multiple containers, then we'll go with the pod. Again, the pod is going to run the containers. The pod is going to run in the backend, the containers itself. If I tell one use case, we are creating an EC2 instance, right? But technically in the Gen server or a hypervisor, what is happening in the backend is it will create a VM itself. Now Kubernetes wise, we are managing is pod, but the backend it is running as a container also, but we don't deal with the container level. In AWS also, we'll deal with the EC2 wise. But the backend, what's happening? Like a VM is getting created, networking, storage, all those at the hypervisor level also is creating. But that's not in our scope of AWS. In the same way here also, those are not in our scope. Those are managed by the Kubernetes itself. Those are managed by the Kubernetes itself we have. Okay. If someone asks about the pod, okay, the smallest unit from the Kubernetes is called as pod that can be deployed as the smallest unit, which is going to encapsulate, storage, networking, all these are getting encapsulated. Okay, so with the pod, these all getting encapsulated. Okay, and we don't deal with the pods also in the real time. The higher level of objects we have on top of that, we are going to use. But when we create a pod, in the backend, it is going to create a in the backend, it is going to create the container itself. Is
Okay.
going to create the container itself is getting created. Okay. Yeah. Any doubts on this? The Kubernetes level, we are not dealing with the container level. Kubernetes is managing at the pod level itself. But even we don't deal with the pods also directly. We have the higher level of objects than pods also. Okay. So and mostly we can have a single container pod. That means one pod, one container, one storage, one networking is there. Okay. So then it's simple and the app doesn't want any helper kind of or sidecar kind of containers. Then we are going to use it. But sometimes a pod can contains a multi-container also. Okay, so then container want to share resources and communicate via local host. We are going to keep we are going to keep multiple containers I want to keep in the same host. Okay, so assume I'll tell one use case. So we have a main app. Main app want to communicate with the log collection agent. That means the same app and the log collection agent want to use the same volume or same networking. Okay, so I want to keep one proxy kind of thing or monitoring kind of agent. This I want to integrate in the pod application pod itself. At that moment, I'm going to use both the containers, but not at all recommended unless we have any specific use case like this. We want to share the like a same host, same networking isolation is to be done. Then we need to go. So now here this is the kind is a pod, and how many containers we need to specify is 2 containers. Okay, so what is the disadvantage is it's a little complex and more resources, more orchestration, troubleshooting also is little challenging. Okay, so that is the reason always recommended to go for the microservice. For one microservice, we are going to deploy one application pod itself. Then we don't directly deal with the pod. So we don't directly deal with the pod. Okay, so we have the pod controllers we have. So what is the meaning of pod controllers is maybe if I go for an auto scaling kind of group, in the auto scaling group, if I create 40 instances, how many EC2 instances are getting created? We don't deal 40 instances. I'll create only one auto scaling group itself. In the same way, even in the real time also, we're not going to use, we're not going to use the pods. We have the pod controllers, mainly 3 types of pod controllers we have. So first one is deployment. Second one is DaemonSet. Third one is StatefulSet. So means we don't directly deal with the pods, but we need to understand so which one we need to choose among these. But all are getting created. The backend what it is creating, the parts itself are getting created. Even if I create auto scaling group in the backend, it's create the instances only, right? I created the deployments or daemon sets, stateful sets. The backend we are creating, the backend what we are creating. So parts only we are creating, but we don't directly deal with the parts directly. We'll create the higher level of objects itself. Okay, so we'll deal with the higher level of objects itself we are going to create. Okay, so now so we have 2 types of applications. One is stateless application. Second one is stateful application. Mostly for the stateless applications. Okay, so we are going to use deployments. Okay, so what is the concept of the stateless application is we are going to deploy a stateless application. That stateless application no need again need to go to the same server. Okay, so stateless and stateful. Say I'm a user, I connected to one application. If something goes wrong, but I want to go to the same session itself, that kind of session stickiness I want, and I want to go to the same node itself. At this use case, we are going to use we need to use the stateless applications. We are going to use deployment kind of thing. Okay, so stateless applications we are going to use. That means I want my application need to be done, but there is no guarantee it goes to the same server itself. Okay, at that moment we are going to use the stateless. But I have my application, even something goes wrong, I want to go to the same pod itself. At that moment, that application is called as stateful application. That application is called as stateful application. For the stateful applications, we are going to use stateful sets. Means directly we shouldn't tell. For stateless applications, I'll use deployment. Stateful sets, stateful applications, I'll use stateful sets. Like this, we shouldn't tell. There is a slight difference. We'll discuss. Okay, the state of the application, like a user session, or maybe like we have like a cookies kind of thing. All are not getting. Whereas the stateful applications, maybe online game or maybe chatting kind of applications. So in the middle also the data need to be persistent. Again, if I start it from the starting, I don't get that data. So in these stateful applications, the session data is going to be stored on the server or in the memory, and whenever the user connects again, the data need to be given. So for this kind of things, we need to choose stateful sets. But if the application is a stateless, we are going to use a deployment. So what is the purpose of the Kubernetes deployment is, like I can specify the number of replicas. So I want 20 replicas, 40 replicas. That number at any point of time, it is going to maintain. At any point of time, those number is running or not is taken care by the deployment. And the updates, rollbacks also we can done at the deployment level. I'll tell one example. Say, assume we have 12 microservices. Okay, so those microservices, we need to choose some of them deployments, some of them may be stateful sets, some of them we may have daemon set also. Mostly for the front-end microservices, for the front-end microservices, for the front-end microservices, will use deployments. For the backend microservices or databases, will use stateful sets. Okay, because we want the persistency, all this. Then assume we have 12 microservices. Front end we have 4, and stateful sets I'm going to use 8. I'm going to use. Okay, so daemon sets we have a special use case. We'll discuss that daemon sets also, in which use case we are going to use that daemon sets also we'll discuss. Okay, so then for the front-end microservices, if I use the deployment, okay, what is going to happen is the replica management. What is the meaning of replica is, for each microservice, I specified the replicas 20 to 40 replicas. Means each one is having 20 to 40 replicas. Then total 4 microservices, right? Then how many parts are running in this scenario?
160.
Yeah, say here 80 to 160 pods are getting running. Why we need that many number of pods? Because more users may be there. The simple pod is not enough to bear the load. That is the reason we are going to create for each microservice multiple replicas we are going to specify. Multiple replicas we are going to specify. Okay. So what is the advantage is,
High availability.
yeah, the application is highly scalable and even highly
Highly
available
available.
also. Highly scalable and highly available also
Highly
we have.
available.
Okay. So then what is the meaning of replica management is, now even if any of that replicas, I need to run minimum 20 replicas, assume. If the 20 replicas is not running, okay, deployment, or we have one more object is there, replica set, that always will make sure that 20 parts are running or not. Okay, so then auto healing also, like it's going to be deleted also if that health is not good, and rolling updates and rollbacks also is possible. Okay, so mostly for the front end kind of microservices. That what is the advantage is like how many number of replicas we have given.
They
Always
have given
deployment will make sure.
the pods are
If I
available.
use parts in this use case, what is the problem with the parts? In this, what is the problem by using the parts in this use case? If I use the parts in this use case, I need to create the manifest files for each deployment. I need to create 40 manifest files or minimum 20 manifest files for one deployment. Like this, if I have 20 means 80 to 160 manifest files I need to manage. Or I need to run 160 times that kubectl commands also. That's practically
Recommend.
not in because in the real time we may have some thousands of replicas also. So mostly each replica will create one. Each replica will create one pod. In the back end, it is creating one a pod is getting created. Okay, so that's what is the responsibility of the deployment is, okay, say creation, updates, rollback,
Scaling,
self-healing,
auto scaling.
auto-scaling, deletion also. All these we can do on the single template file. The template file is a deployment file itself.
Sir, how to delete? Sir?
Yeah, even kubectl delete the deployment is also is there.
Okay.
Okay, so single shot we can do all these operations. We no need to do it hundred of times at the pod level. Say suppose I'll tell one example. We have a retailer and we have a distributor. So we have a retailer and distributor. If I go to the distributor to give one or two pieces, what you will tell? I'm not a retailer. Okay. In the same way, Kubernetes doesn't deal with individual parts. That's the reason we don't deal with the parts at all. We'll create a deployment. The deployment itself will take care all this. Okay. So then if I create a deployment here, two resources are getting created. Okay. One is replica set and n number of parts. N number of parts. So now try to understand here. So here we have this deployment.yaml, right? So kind, if I tell deployment means it's going to create a deployment. Then in this, how many replicas I gave here?
3.
3. If I give 30, what is going to happen? How many parts are getting created?
30 for
30. Who will decide on which node these parts need to run?
scheduler.
Scheduler will decide. Okay, so now here we have otherwise how many YAML files I need to create if it is a pod?
30. 30.
30 YAML files I need to specify.
Sir,
Okay,
you
so
said
now
manifest file, no? Manifest file and this
the manifest files we
deployment.yaml
need to
file.
create 30, right?
So both is same, sir. Manifest and deployment.yaml. Both are same.
No, no. Yeah, so Kubernetes manifest is general word in that we written for deployment resource.
Okay.
This is the manifest file for
Engine is
deployment.
deployment.
Means deployment, okay. The deployment provides declarative updates. Means it's in how many times we represented is we declared only one time, but how many number of replicas we have given, that many times it's going to be creating those resources. How you understand, right? What is the meaning of the declarative updates?
Yes, sir.
Creation, updates, rollbacks, deletion, all that as a single shot we are doing. We are not dealing with
Multiple. We are only doing it
multiple
once.
times. We are not going to manage. Okay. And when I create a deployment in the back end, it is creating one more resource that is called as replica set. Okay. If I create a deployment, automatically I created one deployment and one replica set would be created and n number of pods also are getting created. What is that meaning of n number of pods? In our use case, we have 30 pods, right? Okay, those 30 pods are getting created as a single shot. Okay, so that means when I created deployment, one replica set and that 30 number of pods are getting created. Means one deployment, one replica set. Okay, so now if I run kubectl get deployments, how many deployments it shows?
30.
No, only one deployment.
One deployment, sorry. If you
RS,
get pods, you will get 30.
yeah. The RS means it's a replica set. Okay. So here we can use kubectl get deployments, get RS or get pods. Okay. So now here in this use case, it's going to show one. RS also is one. Pods in our use case is 30. And even we can auto scale also at the deployment level. That means, say normally we can create 30 to 100 based on the HPA is one resource that we'll discuss. Horizontal pod auto scaler. What is the responsibility of this?
It will auto scale.
Automatically scale between 30 to 100 also. But deployment always will make sure 30 are running or not. What is the responsibility of the replica set?
It will make sure that 30.
Always that number of replicas are running or not. Okay,
Okay.
so that is the responsibility. And if those, that's controller kind of resource that is, and if any of the cluster, like one node class, in that we have around 4 pods, then again it will tell to that API server we are not having that expected state. Then again it will create those 4 new pods also. Means if any of the parts have been deleted or maybe not working, okay, if the node got deleted also, that controller will identify and will tell to API server, then scheduler will schedule on the new nodes that at any point of time, my expected state is 30 pods need to run. That's the
Sorry, maybe
responsibility.
I missed it. Like this 30 parts is an example, or like this is a
Yeah, that
common.
is one example in that in our YAML file we kept 30, right?
I missed it. Okay,
So
okay,
that's how many you want. That depends upon your application.
okay.
So maybe if Google kind of application, maybe want some thousands of or maybe some millions of parts also. Okay, so this can be auto scaled also. So just like we discussed in the Geo Hotstar kind of microservice kind of application, if more users are increasing, then definitely the backend microservices need to scale up.
Yes.
But deployment can't do that. We have one more resource for that to do that horizontally. What is that? That is HPA, horizontal pod
Auto.
autoscaler. Okay. So then this is for the stateless applications. This is perfect. Okay. So but for stateful applications, okay, I want some stickiness kind of thing. So what is the meaning of stickiness is I want to go to the same pod itself. But in the deployment, if one pod got deleted, what is going to happen?
Another will be created.
Another pod will create, but there is no guarantee I'll get the same pod ID or pod name. And anyhow, IP address also save. In AWS EC2 auto scaling, can you tell me if I delete an instance in auto scaling group, a new instance may be created, but there is no guarantee we'll get the same instance ID, same instance name. We are not going to get it. Okay, so what is going to happen? A new instance ID only because all the world will have the unique instance IDs, right? Okay, so that is the reason we are going to get a new instance ID. But in
Instance
this
IDs.
also with the deployment, what is going to happen is if any of the pod got deleted, a new pod is getting created, but there is no guarantee that same pod ID, all those we are going to get it. Okay, so then what is the problem is we don't get the same persistency. We
Same.
don't get that. We want the persistency for all these. For the stateful applications, we are going to use the stateful set. And if I use the stateful set, what is going to happen is unique and ordered parts are getting created. Okay, so that's we'll discuss. With the stateful sets, what is going to happen is stable identities. Means every pod will get one identity. Even if I delete that pod also, I'll get that same identity. So I'll tell I created 30 pods. Okay, what would be the name is web
Web
hyphen
0, Web 1.
1, web hyphen 02. Okay,
Web
so in
hyphen
the daemon
03.
like this, here we are going to get web hyphen 30 or maybe 29 maybe, but it started from 01, right? Okay, then 30 will come. So in this use case, what is going to happen is, if my web 05 got deleted, again we'll get a new pod with the web hyphen 05 itself. Okay, in the deployment, there is no such guarantee. A new pod will create, but we don't get that kind of thing.
Then what is
Sir,
what?
we get stable names and all, but will we get similar IP? We'll get
No,
obviously
no,
different
there
IP,
is
right?
no guarantee we'll get the IP because that's like internally it's going to assign by the okay, so
But
we'll get the same DNS name, but we don't get the
sir, if imagine if we are using managed elastic IP, then still we will not get like that or what?
no. Here we don't have elastic IP kind of concept. We'll get the same DNS name we are getting. We are not getting the same IP address.
Okay.
We are not getting the same IP address. We are getting same DNS name and same pod ID. We are getting. Okay, say unique.
I mean, in that case, what point to delete? Like, if I mean, if
No,
once
no,
delete.
that is we are not deleting. It's accidentally deleted.
Oh, okay, okay. I mean, if you accidentally
Yeah,
deleted, then it
node
will
got deleted.
create the same.
Yeah, same pod ID. And for the persistency, like just like in Docker, we have the volumes, right? Definitely here also we need to attach the PVC, all those we need to. Data is there. Even in deployments also we can have a storage. But by adding a storage, we are not getting that statefulness.
I mean, at what point system automate delete such cases? Like, I mean, any specific reason or like
The
something?
node may be deleted or pod may be crashed.
Okay.
Many reasons it will happen. No?
Yes, yes. Pod maybe like here these will have some thousands or some millions of pods are running in the real applications. That's all managing manually is very tough at the Docker level. That is the reason we have an orchestrator. What is our orchestrator?
Kubernetes.
Kubernetes. That will manage even at the some thousands of pods also running also it can control in a better way. So now deployments doesn't create unique and ordered pods, whereas here in the stateful sets we are getting unique and ordered also 1, 2, 3 like this. And updates, rollbacks also happens in an ordered way. Like in a uniform way itself, it's going to happen. Assume I have a 30 parts, then update starts from back. First 30, 29, like this, 28, 27, like this, the parts are getting upgraded. Rollback
Ensure
also,
the high availability. Availability is
deletion also. All this is going to happen at the
for
unique and ordered way. It's going to happen.
sir. So just because it is happening from 30, 29, 28, that is because there should be have a high availability. That's the
Not only in ordered, it should be in a controlled way. It need to happen because the users are already connected.
okay. Okay.
Okay, so that is the reason. That is the difference. That's not guaranteed in deployments.
Okay.
That's not guaranteed in the deployments. Okay, so then like even this is also will manage those 30 parts. All these are running. Okay, but if any update or rollback is happening, it's going to be done in the reverse order. That means in an update order itself, it is going to perform. It is going to perform in an update order. Those are getting updated. And anyhow, definitely for the data, what we need to keep is that part got deleted, right? But the data need to be persistent. For that, we are going to use in the Docker, we are using the volumes. But in the Kubernetes, we'll use PV and PVC. Okay. So then here one more question people will ask in the interview. We have already replica set, right? Why we need to go for deployment? Why we can't go for a replica set itself directly?
Oh, sorry, could you repeat once again?
Yeah,
We
yeah.
have
So we have replica set, right?
work here on deployment.
Replica set is a higher level of object or deployment is a higher level of object? Deployment is a higher level of object. When
Yeah,
we create the deployment, it is creating
replica.
replica set. But replica set also will make sure always that the minimum number of parts are running or not, right?
Yes,
Then why we need to go for a deployment? People will ask. Directly we can create
replica set itself.
a replica set itself. But the problem with the replica set is we can't update or roll back. Means tomorrow I got a new application. Again I want to deploy that one. That's called as update. If something goes wrong, I need to revert back also. That is called as
Rollback.
yeah. So here updates or rollbacks are not possible at even sometimes rollback also means update itself. Okay. So but rollback or updates how we can perform at the deployment level itself we can perform, not at replica set. But we don't directly deal with the replica set also. Means indirectly itself that resource is getting created. When we create deployment, automatically
the
Replica.
replica set
deployment
is
line.
getting created. Replica set is getting in the very older versions of the APIs. Okay, so previously we have one more resource. Now in the newer versions of the Kubernetes, we don't have that. Okay, so we have replica set versus replication controller also. Okay, but the older version itself we have replication controller, but the newer Kubernetes doesn't support replication controller. What we have is replica set only we have. Replica set only we have. Okay. So we'll discuss that replica set and replication controller also. But replica set versus deployment is very, very important. What is the difference? What is the difference between these two?
Back and things in replica set. Right?
Yeah, yeah. So replica set can create the minimum number of resources or pods, but updates or rollbacks are not possible. Updates or rollbacks are not possible. But if you want to do the updates or rollbacks, what we need to do? Deployment itself we need to use. Deployment only we need to
You
use. Okay. So that is the reason we are not using
replica set.
replica set, we are not using. Then we have one more resource is there. So now here, stable pod names and ordered startup and shutdown. Each pod it's get their own PVC. And for stateful applications, workloads like databases or Kafka, Cassandra, or for message queues, backend microservices, better to use the stateful sets. For the front-end
Sir,
microservices, recommended to use the front end is UI kind of things. For those we can use deployments.
sir, what is difference between PVC and PV?
Yeah, yeah, that's we'll discuss. Okay, so PVC is like actual climbing. PV is a driver or some storage class we are going to attach. We'll discuss that. Okay, but actually to the pod we are attaching PVC, persistent volume climb.
Uh,
Okay, so then here we have Kubernetes daemon sets. What is the purpose of the daemon sets is, assume in the previous example for the stateful sets or deployments, I'm going to specify 30 replicas. I specified that 30 will be running. But if I use the daemon set, I no need to specify that number. On each and every node, one pod would be running. Okay, so I have 20 nodes in my cluster. Then how many pods would be running?
20.
20 parts. I no need to specify that number of replicas. I no need to specify that number of replicas. So what we can do directly? What we can do directly? Automatically that can be like if I create a deployment, if I have 20 replicas, that's going to run on 20 nodes. 20 nodes is going to run it. I hope you got it right. Daemon set will make sure. Assume I have one one flat have 4 rooms. If we want to observe 4 rooms, then how many CC cams I need to keep? I want to observe all my 4 rooms. Then how many CC cams minimum I need to keep?
4.
1 to
Yeah, one if I keep all rooms I can't observe, right?
4.
yes, sir.
Yeah, then minimum I need to maintain in each and every room I want one CC cam or not?
Total 4 we needed minimum.
Total minimum 4. That's if I use 4 itself, but that guy may install all the 4 in the reception only, right? Maybe or maybe in the hall only. Then what I'm missing? I said 4 cams, but what he did is he kept all in the hall itself. Okay, but what Daemon set will make sure? On each and every node, one pod, I no need to specify anything. But if I specify that as a deployment, there is no guarantee on each and every node it goes to. Okay, so I'll tell one example. I have 20 nodes cluster I have. Then I want to run one application. Okay, then if I go for the deployment, if I specify 20 replicas, there is no guarantee on each and every node one pod will run. Okay, so that's who is going to decide that?
Daemon
Scheduler is going to decide.
schedule. But if we use DaemonSet, it will
Daemon
make
said
sure
what it
that
is going to make sure is
at least one
on each and every node only one pod. For the second, it doesn't allow to run on that. Because already I kept CC cam in the room one, right? Then again I don't need to keep one more. Okay. So then here we have some special use cases. Why we need to go for the deployments. Okay. So maybe for log collection agents. Okay. So that means I want to collect all my node level logs, right? Okay. Monitoring. Just like CC cam for the room. For the monitoring, we have monitoring agents, security or antivirus. These all I don't need to run multiple running. All these will cause problem for me. Only one is required. Okay, and that's all in each and if any of the node is missing, also what is the problem to me? If any of the node is also is missing, what is the problem? If any of the node is missing, also what is the problem?
we will miss on availability.
Yeah,
I guess.
that's that I don't get that agent logs, right?
Yes.
So that is a challenge we have. Okay, with the deployment or stateful set kind of thing for this use case. We have a log collection agent, monitoring agent, or CSA kind of drivers. Okay, that should be running in each and every node. If we want to run, then we need to go for daemon sets. So we need to run for
DaemonSet.
the daemon sets. Okay, so mostly for your application microservices we don't use. On top of your application microservices, we required like maybe log collection agents, monitoring agents. Okay, so for that we need to use. So for
Daemon
that we need to use the daemon sets. Okay, so your application like mostly for the front end microservices, stateless applications, you are using deployments. For the backend, all are getting created parts itself at the finally. All are getting created parts itself. Okay. Then we have the technically differences. Like deployment will have something, stateful set will have something. Okay. So for the front end microservices, we'll use deployment. For the databases, Mac backend. Fluentd is a log collection agent kind of thing we are going to use. And what is the responsibility of the replica set? Replica set, like always, will make
it
sure
will make sure
that
that
specified number of pods are
pods
running
are
or not.
running actively. Yes.
Okay, but we don't directly deal with the replica set. We'll use the deployment itself because rolling updates, rollbacks, all these are managed by deployment, not possible with replica sets. Okay, so now here rolling updates, rollbacks, version history, all these are not supported by
Replica set
replica sets. Those are taken care by
deployment.
deployments. Okay, but one replica set YAML 95% or 99%, both looks like same itself. Deployment.yaml, pod.yaml also is almost same. Okay, then replica set also it looks like almost same, but we have the different use cases.
Sir, but in some deployment.yaml files, no, I saw a replica set is mentioned in that. No?
No, replicas is mentioned, not replica set.
Okay.
That replica set, that number, how much we have given, that will make sure that is running or not. Okay. So I'll share this document and try to provision that Kubernetes cluster. See, EKS cluster, try to provision. I shared videos for that. EKS either through Terraform also, you can provision that. Okay. So that try to provision by tomorrow. So we have a Terraform tutorial also we have for that. So we know the Terraform tutorials, right?
So one doubt is basically we need to have Docker. We need to have Docker desktop open in
No,
which
no.
you have to.
Desktop is only not for a production.
Sir, but
Okay.
when I was practicing, no, I was told. I mean, I somewhere saw that Docker desktop will have Kubernetes turn on bulk option. Is that how we do it, or how
That
do we
is
do
only
it?
for testing purpose or dev purpose.
So we use kubectl this
Yeah,
thing and
kubectl.
using that.
Yes, yes, yeah. So now here if we go for this, better to run on the cloud. So here
EC2.
we know these tutorials, right? In this AWS, so we have a provision and so this tutorial from the Terraform, like spend lot of time, minimum 30 to 40 minutes you spend to confirm what are the Terraform modules they use and how the resources are getting created, all that. Try to provision the Kubernetes cluster from that. So this is just 9 minutes one, but spend lot of time on that GitHub repo.
Okay.
Because even in the real time also, we need to tell this I have developed by own. That module also we have developed like that, we need to tell. Okay.
Yeah.
So that's try to finish by tomorrow. Either through GUI try to finish or from EKS
Sir,
cluster wise. From going forward next classes, we need a Kubernetes cluster is required.
Do you
Okay.
need the Kubernetes cluster? Where here it will provide
In
all the things.
AWS we need to.
Okay.
So through Terraform, we are creating in this tutorial.
Okay.
Just like how we created EC2, almost all same steps.
Okay. Okay.
Okay.
I use Visual Studios. Mm,
Yeah, you clone that and you use the same steps.
okay.
Okay.
why are we not doing it in the